All right, this time around we are looking at 8.2, graphing ax squared plus c. So again, like yesterday, like in these problems here, we really want to remember our parent function that's right here. And we're still going to use those numbers 1 and 4. Let's look and see somewhere that I wrote that out nicely. Right here, I had the numbers 1 and 4 representing that these red dots were up 1 unit and the orange dots were up 4 units. Over here, we had a vertical shrink by a half, so I multiplied by a half, and then our verticalness was now 1/2 and 2. So, looking at section 2 here, if it shows up, there it is. The plus c is going to move it up and down. So here it says whenever c is greater than 0, ax squared is translated up c units, and then whenever he's less than 0, he's translated down. This really moves the vertex, and that's what we're going to think about here. So number 6, we have this plus 2 that moves it up 2 units. The transformation here is up 2. Now we look at graphing it, and I'm going to draw a plane here. And I'm going to first copy down our parent function. So he has a vertex 0, 0. He goes up 1 over 1 in both directions, and then he goes up 4, 1, 2, 3, 4, and over 2 in both directions. So there's our parent. And then our new graph, let me call this guy f of x equals x squared. And then our new graph is going to be moved up 2 spots. So I take that vertex and I count up 1, 2, and then the other 4 points also go up 2, and you can either count up 1, 2 and put them there, or you can just remember up 1 over 1 in both directions, and then up 1, 2, 3, 4 and over 2 in both directions. I didn't draw that point very good, but there we go. And then I can draw in my curve. And this is going to be g of x equals x squared plus 2. And that's it. That's as hard as this gets. Number 7, it says to describe the transformation and compare with the parent. Now, I know I said that's as hard as it gets on the last one. This one has just a little bit of extra, not necessarily harder. The 1/2 is a vertical shrink by a half, which we already did in the previous lesson. So it's not harder, it just combines some things together. And then the -4 is going to tell us to go down 4. So those are the transformations that we have occurring here. And now we want to get graphing. So I'm going to draw a nice coordinate plane. Now this time I had to go down 4, so maybe I want to draw a little bit more in the negative area. We'll just put a few tally marks. 1, 2, 1, 2, 3, 4, 1, 2, and let's do down. How many do I have to go down? Down 4. 1, 2, 3, 4. Our parent is going to be the same as before, and I want to copy him down. So there's our parent, f of x equals x squared. Our new graph was moved down 4, so I have a vertex down there at -4, and there was also a vertical shrink by a half. So I need to get out those numbers 1 and 4 and multiply by a half on both of them, just like on the example from yesterday. This gives us 1/2 for our first set of points and 2 for our second set of points. So this first set, and I'll draw these in, we'll draw them in orange. These points, I go up a half and over 1 in both directions, so just a little bit higher. And then our other points, I'll draw them in blue. We go up 2 and over 2 in both directions. And then I'll draw in my curve, and I'll draw it in red. And I want to label that. This is g of x equals 1/2 x squared minus 4. And there's our graph. Let's look down at number 8. Let f of x equals 4x squared minus 8 and g of x equals 4x squared plus 6. Write an equation that represents g in terms of x. So we want to rewrite this g of x but we don't want to use f of x here. We want to get rid of f of x. Well, this is really just going to be substituting in. This left highlighted piece is f, and then over here we have f, so I'm just going to say, I'm going to plug in 4x squared minus 8, so this is f, and then at the end we have a plus 6. So g of x, combining like terms, 4x squared minus 2. And that's it. What g, you can think back to g. G is f, but moved up 6. And if you look at f was moved down 8. So if you start off down 8, and then you go up 6, well, together you're down 2, which is what we have listed right up here. There's number 8. Let's look at our next one, number 9. Graph g of x equals negative x squared plus 1, and then we need to list all of the characteristics there. So, again, I need to list off my transformation. The negative is a reflection in x-axis. The plus 1 moves it up 1, and now we're ready to graph. I want to draw my plane out. Like before, I want to graph my parent first. So I'm going to graph at 0, 0. Then I'll put on a few points here, or a few tallies there. Up 1 over 1 in both directions. And then I'll go up 4 and over 2 in both directions. So there's my parent. Hopefully by now you're getting tired of me graphing the parent. That's a good thing. We want to be making sure that we have that stuck in our head. This is f of x equals x squared. Our new graph was moved up 1 spot, so I've got a dot up here at positive 1. And then I'm going to think about the numbers 1 and 4, and they have a negative 1 that they're multiplied by. So it's negative 1 and negative 4. So they're going to be going down. So down 1 and over 1 in both directions. And then down 4. So that's 1, 2, 3, 4, and over 2 in both directions. So this is our new graph, g of x equals negative x squared plus 1. Now we want to list everything that we can. Starting off, we have the vertex here. The vertex is at the point 0, 1. And this 1 we could grab directly from there. And then our symmetry line is at x equals 0. And remember, that corresponds to the x value of our vertex. Next up, we want the domain and the range. The domain is going to be all reals. And again, we look for a domain restriction, and there is no domain restriction, so that means he's going to be all reals. The range, we look for where is the top of our graph. We have the top of our graph right there at 1. So our range is going to be all the y values less than or equal to the top, which is 1. And again, this is the same 1 that we used up above. We want the positive and the negative intervals. The positive interval, actually, you know what? Let's first talk about the x-intercepts. Those we can see really quickly are at negative 1 and positive 1. Negative 1 and positive 1. I'm looking right here at the spots where they touched our x-axis. The spots where it touches our x-axis is where it changes from positive to negative. So our positive region is the middle there. That's going to be negative 1 less than x less than positive 1. And then our negative is going to be everywhere else. So we'll say x is less than negative 1 and x is greater than positive 1. So there's our positive and negative. We did the x-intercept. Let's go ahead and do the y-intercept. It's right there. It's part of our vertex. It is 1. And this is actually the same 1 as before. And then lastly, we want to do the end behavior. and we look at our arrows. Our arrows are both pointing down, right? Those are our arrows, they're pointing down. So we can say that it falls left and right. That's one way of writing it. And the way that I prefer is as x approaches positive or negative infinity, y approaches negative infinity. This means as x goes left or right, y falls. And the reason that I like this way of writing it more is because later on we're going to have what's called asymptotes, and we can use it to describe in behavior still. What's our next problem look like? Let me see. Let's go ahead and skip 9.5. You guys can do that one on your own if you'd like. And then let me look at number 10. Number 10, we have the negative out front. That's a reflection in the x-axis. And then we have the 1/3. That's a vertical shrink by 1/3. And the -1 tells us to go down 1. Now let's get to graphing this. Now I'm going to graph this without drawing the parent function in. If you still like drawing the parent function in, or if you don't have it stuck in your head yet, you need to graph the parent. I have the parent in my head, and I think that you might by this time too, so I'm not going to graph it. We have that our graph went down 1 unit, so there's our vertex. And then I'm going to use the vertical shrink by 1/3. I'm going to use the numbers 1 and 4, and I'm going to multiply them by -1/3. That gives me -1/3 and -4/3. So for my next points, my first set of points are going to be down 1/3 and then left and right 1. Now that doesn't look perfect on our graph, but it's really hard to get to 1/3, so we would just want to do something that's close. And then -4/3, that's -1 and 1/3. So I'm going to go down 1 spot and then a little bit more, and it's going to look something like this. And there's going to be our graph there. Now I'm going to let you guys on your own write down the vertex, the symmetry, the domain, the range, the y-intercept, the x-intercepts, the, what do we have, the positive, the negative, and our in behavior. Now as I say that, I realize there's some special things here. I think you guys can do the vertex, the symmetry line, the domain, the range. Let's look at our y-intercept. That's at -1. Our x-intercept, we actually have none this time. It doesn't touch the x-axis. Our positive region, we have none. And then our negative region, it is always negative, so he's going to be all reals. And then you guys can get your in behavior. So make sure on this problem that you fill in your in behavior, your range, domain, symmetry, and vertex. All right, there we go. That is section. Just like now, we can go up or down. Right? We're not moving left or right. I think that's tomorrow. We're just moving up or down. All right, that's section 2.